equations, bunch of theories, do this for this test, do that. That is really not going to stick. I'm pretty sure. I think as long as you have the basic idea of why you're doing it, the very basic as to how you do it, what's the fundamental principle. All other things have nuance, special details, nuances. You can find from books, or you can consult an expert to do a specific job. But if you know exactly why you're doing it and what are the basic principles, that will stick. I think that's all we can, if we can get out of this, that's all I care really. So this is not a rhetorical question. This is really because I really believe no matter what you do, it doesn't have to be statistics. It could be your own research. It could be your class you're taking. If you don't buy into the idea that this is a worthwhile endeavor, it's useless. You're just going through the motions. So what do you guys think? So what I'm trying to say is that typically statistics in our context, we're using it for data, looking at data, making some judgments, inferences, and so forth. So the idea, so everything is from your data, right? So then there is nothing new in that statistical presentation. It's all there in the data because everything is derived from that. So my sort of suggestion is I just give you all the data. You go and make measurements of motility. I'll give you all my motility, whatever, the speed of motility, direction. I'll give you all the data collected. So why not? Why not? So why are you unhappy? Or why are people unhappy? That they have to do something more. So obviously, Partha did mention very first one that really it's information overload, basically giving all the data. You just want to describe your sample that you have, what characteristic they have. So just describing few things captures the essence. If not all of it, 95, 98% of what you want to say from the data, the raw data, it's captured. So that comes under this category called descriptive statistics. So that's part of the thing that's where you begin. What other things are useful? Why wouldn't I just give you data? So Dave goes and does a study of profilin knockdown and wild type and does motility studies. Okay, I give you these two sets of data. So one is like 25 micrometers per second, other one is 10 micrometers per second. Okay, 25 is bigger than 10.
I guess this would be to draw a conclusion about whether an experimental condition has any effect, like inference.
Right. So that's comparing. Basically, you want to compare those things, and that comes under hypothesis testing, kind of. You have certain hypothesis, and you see testing. So that's another use. Any other use? And by the way, then why wouldn't I give you 25 micrometer per second in one case, 10 micrometer per second in another case, 25 is bigger than 10? I'm home free. Why do I need statistics?
Just check the variability.
Yeah. So there is so this idea. This is the core idea of everything you do in statistics. There's a variability of and then we need to talk about where does the variability come from. But there's clearly variability. There's no God-given one number, right? But there is a possibility of having a number without any variability at all from measured data. What would be that circumstance? Let's say I'm interested in knowing heights of people in Pittsburgh. What is the height? So, mean height, people living in Pittsburgh. There is one experiment that you can do which will result in zero variability of that mean. What's that experiment?
Sample size is smaller.
Smaller?
More
No, one. No, that's not possible, right? That's just other. So
You
there's
use
one
the
experiment
sample
where there is absolutely no variable. Huh?
Compare the same person over years.
No, that's
No, no.
not changing.
My goal is to know the mean height of people living in Pittsburgh. That's my goal. So there's one experiment where there's absolutely no statistics needed. Just mean.
You measure it today and then tomorrow, and then within
Then
a day
it's
there's
a
not
change.
too much change.
Now it's even simpler. And
You
that's
just take a population of people and you pick the person who you deem to be the average size.
no. Well, how do you know? How would you figure that out?
People are going to be different heights, and you just.
How would that?
In this
that-
room,
you already have a
we all stand up, line people
So
up,
you're-
from the tallest to shortest, take the person in the middle.
You're,
Measure them.
you're almost there, but guys, it's a simple, very simple, nothing to, so,
Take a bunch of people at the same height.
no. Well, then by definition,
Probably
you
the
eliminate it. I need to know the mean, and that mean would not have any variability associated with it.
Just one sample.
No, that's what he said. That's not.
Large
Guys,
population.
think. You will go and measure the height of every person living
Yeah.
in Philadelphia. I mean, in Pittsburgh.
Yeah.
Everyone, no doubt omit anything, and take an average. That's a real average. That has no variability associated with it. The reason the variability is associated oftentimes for the mean. I mean, I'm saying I'm asking for mean, not the variability of how the height. Because we take a sample. We don't have the luxury of taking every possible measurement in that thing, and that creates a random sample creates a variability in that mean. So the mean is not in that case. So my question was, I want to know the mean height of people living in Pittsburgh. That was my end result was the mean height, and that as a number. If I went and made measurements of every person in Pittsburgh, there is no variability in that number. That's a number. It's a real number. That's what's called population. But in statistical thing, we don't have the luxury, we don't have the resources, don't have the time to do it. So we take a sample. And so depending on if you repeat the samples, I'll get different means. And therefore, that mean that I'm after it's not a fixed number there. It's variable. And therefore, we get some variability there. Right? So the idea is that the only thing I told you about population versus sample. Population is something that is an exhaustive membership of that particular entity, and sample is just because we pick some random subset because of all the practical constraints. Okay, so but anyways, what other utility of statistics may be other? One is sort of this large number of data, raw data, we just want to condense into some manageable stuff. That's
So
compare things, right? What else?
Kind of prediction trends,
Say it again.
trend, some kind
Trends. So yeah, I mean, it's basically it's this. Oftentimes, we want some relationships. We begin with sort of empirical, and hopefully, at some point, it may become cause and effect. Statistics will never give you cause and effect, but at least it will give you trend, and it's up to you to understand the physics, the biology, and try and understand. But these are relationships. Try and understand, and so those are into the category of regression analysis. So you got descriptive statistics, simple stuff, mean standard deviation, blah blah blah, median, percentile, whatever. Hypothesis testing, comparing groups, two or more. Relationships. And for us, it's important because those relationships, initially strictly based on statistics, may ultimately lead to some biological cause and effect. So relationship. What else?